Hey everyone, so it is your first video I think for this system design course and I am sure you absolutely love it. So in this first lecture I want to tell you something about system design, why it is important and how it started. So in the long back with I think it's Netflix, there is a show is streaming all over the world and people are watching it, and suddenly what happened that the show is crashed, the videos freezed and everything just slow it down, and everything is like freaking crazy. Okay, Netflix, what it is happening, why it is we paid for you, we are your subscriber. A big question mark, why? So in that way, it is a case of 90s actually, and in that way people realized, okay, we have to think about a system, like how to scale the system in a proper fashion. In that context, there is a way called system design evolve, like designing the system to collaborate and work. This is called system design. Okay, so let's like how you design your system to handle loads, preventing the meltdown 503 when your site is crazy freaking viral. Okay, so let's suppose take an example. You are running a site. Suppose it's like mm, a t-shirt store. Okay, you are running a t-shirt business, and you create some kind of store for that. And you some what happened, someone from influencer take a t-shirt from your app and put a link. Okay, this app is crazy, and apparel that they have is crazy, buy this, and that reel is shooted up like crazy number of people came and visit your app, and your system is not know by this effect that okay, this kind of thing will happen, this person come and will give some, like, give some freebies for your site, and like the site is up crazy, the site load is up crazy, your system is doesn't aware of that. So what will happen, your system got a crash. Why? Because it does not have enough resources. That you think that you doesn't aware of that, you do not aware that okay, we do not aware that this might happen, and you do not allocate that much of resources to your site application or something, and your site gonna crash. People people will check your application, okay, and they see 503, a big 503. So they said, okay, might be his t-shirts are good but the site is down, and then I think these are very negative sentiments. So that's why system design is important, because you never know what will happen in this AI era. Okay, so let's move to the let's we take the lesson. Okay, why system design is important, let's move forward. Okay, what it is actually. So I want to talk about some system design's main pillar. What is the main pillar of that? So first off is building blocks. Building blocks is like suppose what is building blocks? Suppose you have a Chrome browser, okay, and the users exist like see your website over your Chrome browser with the help of site, your domain. It's another case. Then there are the servers. What is servers? Servers are the place where your data stores, like your site information store, your cart information stores, your t-shirt stores, your transaction history stored, everything resides on this servers. Okay. Now the communication between this and this is done with some kind of APIs, and they communicate over HTTP. So this is called building block. The client, the servers, which is called as database, and we have CDNs also to cache the things and all that. So these are the some fundamental building block of system design, like basically how the like suppose you have create Maggie noodles, so you need water, and then you need Maggie, and then you need masala, Maggie masala, or some all the utensils you need. So these what these are called building blocks. Now handling data between them. So how you handle data between them, like you need network calls, you need APIs and all that. So you need how you make sure that all these are communicate properly with all of them. So it's like you have Maggi pasta, you have you have your masala and you have water. How you put in a pan to make the Maggi, in that segment it is. And how these behave at scale means, suppose your site got like influencers, they put, okay, this t-shirt is crazy, you must use that, and the stock got too much high. So how your system behave at that moment, and then at the last is cost and trade-off. Like it's not a situation, suppose you are running as a business and your t-shirt cost all the t-shirt apparel cost like 3 crores, and your site that is handling all the logistics and business, just taking in the user on the site, is like 4 to 5 crores, so the net revenue is negative. So it's not that also. So these all the things that we take off in the situation, like system design is the main pillar. Or also there is a 99.9%, the three nines, and 99.999 uptime SLAs. These are the sum of also some, these are kind in trade-off also. So it's like uptime, like my side, we said, like some big provider said that, okay, we provide a system that make your site always 99.9% up. Okay, let's take a case study. Suppose you have a laptop, okay, and suppose you have a laptop, and in that laptop you are doing something like 5 to 10 tasks, okay, and suppose you want to do like your 12th task. Are you able to do that? No, your laptop is lagging. Your laptop is like begging for you to get you more RAM, get you more something, more resources to allocate, then it will work. And after 12 to like 30, the system crash and your laptop will slow down, and ultimately it might be shut down too. Your all the tasks will crashed. Okay, so in that way the system design also work. You have to think before, like what will happen, how this happen, why this happen, all the thing in the system design. Okay, let's talk about some main pointers in this system design course. First, the main point in system design is scalability, like scaling the things. Like suppose you have a product, suppose you have an application, and your application is good with 1000 users. Should it good with to 10,000 users? Should it good with to 10 lakh user, and all that? Okay, now, availability means your site is how much time your site is available to internet. Like it's 99.9% of uptime, like it's always available. It should be. There is a like 100% off also, but it's very rare, and like I don't know what's near to impossible. There are glitches and everywhere, and each time there is something is running behind the scenes, so you don't know what will happen whenever will happen. The third pointer is low latency. Low latency, what low latency means, suppose you ping, you are using an application, and in that application you are using some messages, and your internet is good, and you ping someone, and that ping is going like 3 seconds. Suppose it's a very less time, but it like take 3 seconds to deliver that message to another person. You will just quit the application and download another fast one. So it's latency is very important. This is the generation of reels, and this reels generation, the people latency is also slow, so it's also high. The third is consistency. Consistency means data should be same in all the db. Suppose you have a primary db, and we have a replica db a, replica db b, and replica db c. So in all these dbs, the all the data, if of or the same data, then should be same. Or you can say Google Pay finance, in which we transfer some money to someone, then it should be this consistent, like it's not change with time. Throughput means, suppose we have a Google Pay, and like Google Pay is using 100 at one time, like on a 1 second of this. When you're watching the video, there is 100k people using GPay. No one should experience a lag, no one. So this is throughput, like on a single time, on a single moment, on a single second, how your site react in that moment is called constant. Fault tolerance is simple, like when your site lagged or like any component fail, how your system interact to like solve it without like intervening to none and like giving 503s to user for some time. And security is, basic, like a malicious attack and any activity done by active attackers on your site, then it's called thing active security. Case study, Google Pay. I gave you the example of Google Pay, how Google Pay is using like security as scalability, like you have to scale it like to the millions of users of India, how it's available every single time. And the best part is latency. Is like you done a payment, you do not want to wait to 5 minutes to just show the payment is completed. It will take like roughly 3 seconds to complete all the payment procedures, and you will get a single tick sign and you're good to go. And the other part is like uh what to say, oh, sorry, throughput, like on a single moment, on a single second, like if we take a roughly, then 1000k of people are using Google Pay and everyone's got a smooth experience. So that's it. That's the first part of system design. Hope you like it, and in the next part we will exploring more of that. And if you came here to the end, please do not forget to like and subscribe to this channel. Thanks for watching.